Okay, in this video we're going to talk about binomial probability and how to calculate that. There's some key ingredients for this type of probability, and we're going to relate it back to our binomial theorem. So I've written this up here at the top. Hopefully you've had some time to practice with that. I would almost recommend doing the practice problems with the binomial theorem first. Practice with that calculation and then come back to this video. And then we're going to actually take this, and you'll notice these equations that we use on this look very similar to the binomial theorem. So let's talk about what is binomial probability. So remember, binomial means two terms when we talk about that. So when we talk about binomial probability, you're talking about something specifically that has two outcomes. Either it happens or it doesn't. So if I'm going to create a binomial probability experiment, there are some things I need to have. First, there has to be a fixed number of trials. So if I'm going to go out and perform an experiment, there can't be an infinite number of trials. There's a fixed number of trials. Secondly, each trial needs to be independent of the next. So my performing the first trial is not going to affect the outcome of the next trial in any way, so that I can calculate those probabilities. Third, there can only be two possible outcomes, right? So that's what we mean by bi, and it's either success or failure. Now, failure doesn't mean failure in sense of the context of the experiment or problem necessarily, but you get to define what is success, what am I looking for, and if that doesn't happen, then that's failure. So it happens or it doesn't. Okay, and then fourth, the probability of success must be the same for each trial. So the probability of something occurring can't be 3/5 the first time I do it, and then 6/5 the next time I do it. Oh, can't even be 6/5, 5/5. So those are the types of things that we're going to make sure that all of our experiments that we talk about here when we're calculating binomial probability, that they apply. Okay. When we calculate binomial probability, what we're going to do is we're first going to define the random variable. Now, what does that mean? The variable is just based on the number of successes that we're looking for. So whenever I figure out, okay, well, what's the experiment being performed? Then I take a random variable, and for some reason we use capital X to define a random variable. And I usually use a little squiggle line. And then I define what is success. So I'm going to actually define what is success for my experiment. Then as I go and I perform the experiment, or I calculate things related to the experiment, now I know that I'm looking, when I calculate for a certain number of successes. So you'll notice over here as we start to put this together, we're finding the probability of a certain number of successes. Okay, so I've defined what success is. Now I'm looking for maybe 2 of them, or 3 of them, or 5 of them. And then we're going to plug it into this formula. And what we do is we say, okay, well, out of how many trials are we going to perform them? So that's like our n value with our binomial theorem. So you'll notice the n here. Out of how many trials, how many successes are we looking for? Once we define those successes, we say, okay, well, what is actually the probability of success? And we want to see success k times, right? That's how many successes we're looking for. And then all the rest of the trials, they can result in not success or failure. So then we would use the probability it doesn't happen, right? Totally crazy, maybe confusing, so let's kind of go through and make sense of this. I'm going to write this out in this form. This is the calculator form, so I'll show you also how to calculate these on the calculator. Let's do it all by hand first, and then I'll come back to the calculator. So first of all, here's an example. Find the probability of a basketball player making 4 out of the next 5 3-point shots, given that his stats show that he makes 65% of his attempted 3-point shots. Again, let's make sense of this. Notice there are a fixed number of trials. There are 5, right? He's only shooting 5. How many successes are we looking for? Well, first of all, let's define success. So if I define success as him making the 3-point shot, so makes the shot, then when I calculate the probability of my success, or him making the shot, that's what that's going to look like, and I can do that. Probability of failure then would be him missing the shot. So those are the two probabilities that we're going to need in our formula. So again, we always define it first. So if I define the probability of him making the shot, we are told that he makes 65% of his shots. So there's all these things that we're considering. And this example, I've listed this out to kind of break it down for us. So first we define the trial. Well, he's shooting, right? He's shooting a 3-point shot, and he's going to shoot 5 of them. I guess that's the next question. So he's shooting a 3-point shot. Sometimes I get ahead of myself, especially after I teach this all day. How many total trials are being performed? Well, he's going to shoot 5 times. What is the number of successes that's being considered? So we want to see 4 makes. That's what we're looking at because we defined success as making the shot. Then it says, what's the probability of success for any given shot? Well, if he makes 65% of his shots, then this probability of success would be 0.65. And that means that he must miss the other 35% of the time. So if he makes 65% of the time, he's missing 35% of the time. Then it says use the binomial probability formula. Okay, so again, this is how we write it. We say the probability of 4 makes. So we use the X to represent makes. Remember, that represents made shots. And we want to see 4 makes. So I'm going to skip the calculator part for a minute. So what we're going to say is N, which is 5. He shoots 5. We want to see 4 makes. And then we say the probability of success on any given shot is 0.65. And we want to raise that to the 4th power because we want to see 4 successes or 4 makes. The probability then that he misses is 0.35 on that other make. So what we're doing when we look at this is we're saying there's 5 trials and we've accounted for all 5. What's the probability he makes these 4, misses this one? And we're going to go ahead and calculate that. Again, if we calculate that, 5 choose 4. And you can put this whole thing in your calculator once you have this guy right here. I'm going to show you real quick. So here's our calculator, hopefully. And we're just going to put the whole thing in. So we start by going math. We go over to probability to that choose from the we practiced on the last video. We go 5, choose 4. Then we put in 0.65 and we raise it to the 4th power. Then we put in 0.35 and we raise it to the 1st power, or it can stay as is. So when we push enter, that gives us 0.312. And I'm going to round out to at least 3 decimal places. So if we look at this, again, we're at 0, back to my laser, 0.312. So the probability, right, that he makes 4 out of the next 5 shots would be 31.2% or 0.312. Okay, let's try that on a couple of these other ones, and then we'll talk about sometimes we can have more than one outcome that we're considering. So here it says, a blindfolded marksman finds that on average he hits the target 3 out of 5. If he fires 4 shots, what is the probability of, we've got 2 hits, more than 2 hits, at least 3 misses? Okay, so as we look at this, again, we get to define success. So because this is relating to hits, I'm going to call success him hitting the target. Then I look at, okay, well, what is the probability of success? So what's the probability he does hit? And it says he hits 3 out of 5 times. So 3/5 would be the probability he hits. So then the probability he misses would be 2 out of 5. So if he hits 3 of the times, he misses 2 of the times out of the total 5. Okay, so as we set this up, we're going to use those probabilities. And what we do is I'm going to use this notation so we practice it. We say the probability of getting 2 hits. So our random variable x equaling exactly 2. Again, he's going to fire 4 shots. So that's important that we know how many shots he's firing. So he fires 4 shots, and we want to find the probability that he hits twice. So we do 4, choose 2. The probability he does hit is 3/5, and we want him to hit 2 of them. Probability he misses is 2/5, and those are the other 2 because he's shooting 2 or he's shooting 4 total. Again, then we can plug this whole thing in our calculator, so let's do that one more time. come over here and we go to math, over to probability, and we go to number 3 and we say 4, choose 2. Then we go to 3/5 and we raise that to the second power. We do 2/5 and we raise that to the second power, and we end up with 0.3456. Well, that's crazy. 3456. 3456. That one came out nicely, so I'll just leave that whole value there. The next one says more than 2 hits. So when you think about this one, if I'm using this notation again, what's the probability that x is more than 2, right? Not equal to 2. So this one, we have to consider more than one option. More than 2, if he's shooting 4, means that he's going to hit either 3 times or he's going to hit 4 times. That would be the probability of success, right, of him hitting more than 2. So we've considered all the options. So if I'm setting this one up, I'm going to have 2 different pieces. So first I'm going to start with this x equal to 3 piece. So I'm going to do 4. He shoots 4 and hits 3 times. Probability of success is 3/5, and we want him to be successful on 3 of them. Probability of missing is 2/5. That means he misses the other 1 out of the 4. Okay, so that's the probability of hitting 3, or he can hit 4 because that's still greater than 2. So now we do 4, choose 4, and the probability he hits 4 of them, so we have 3/5 to the 4th. And then we could write 2/5 to the 0, but he's not going to miss any, so we don't need to really include that. Again, you can go ahead and put Okay, so we can put this whole thing into the calculator at once. So I'm just going to jump to the calculator, and I've already put this in, so I'll just kind of show you. Here at the bottom, notice we can just put this whole thing in. You've got 4, choose 3, 3 divided by 5 to the third, 2 divided by 5 to the first, plus 4, choose 4, 3 divided by 5 to the fourth. And that came out as 0.4752. So here we have 0.4752. Okay. On this last one, this says the probability there's at least 3 misses. So at least 3 misses means that he either hits none of them, right, or he hits one of them. So we could do this as the probability that he hits none of them, or the probability that he hits one of them. So if we're looking at this, we could set that up the same way. Again, we do 4, choose 0. He's not going to hit any of them. So I don't really need to put 3/5 to the 0, but you're just recognizing 0 of them have success. Probability of missing, we raise that to the 4th power. Plus we go 4, choose 1 for the 1 hit. And we do the probability of success for one of them times the probability of failure for the rest of them. And you can plug that whole thing again into your calculator. 4, choose 0. and so on and so forth, and you should end up with 0.1792. I would plug it in and make sure that you end up kind of getting the same thing there. Okay. All right, let's talk about this last one, and then I'm going to talk to you about using the calculator. According to a survey, about 62% of adults have visited a dentist in the past year. You ask 5 randomly selected adults whether they have had a dentist visit in the last year. What is the probability that more than 3 people surveyed have visited a dentist in the past year? So again, you get to decide what success is. It said have visited a lot, so I'm going to say it sounds like we're talking about people that have visited it, and people that have not. So have visited the dentist, I'm going to call that success. And it looks like the probability they went to the dentist was about 62% of adults. So 62% have gone, which means the probability of have not gone is 100% minus that 62%, so 38. Okay, so again, it says, what's the probability that more than 3 people, so the probability that X is greater than 3. Well, more than 3 people means at least 4 of the 5 he asked went, or it could be 5 went, right? So 4 or 5. So again, let's just plug this in. He's asking 5 people. So we do 5, choose, in this case 4. The probability they did go to the dentist is 62%. We raise that to the 4th power. And then the probability that that last person did not go to the dentist, 38%. So there's the first piece. Then we say plus, and now we do X, the probability that all 5 did. So we do 5, choose 5. That means that all 5 of them went to the dentist. And I'm going to add this just so you see it, but that means that 0 of them didn't go to the dentist. So I'm going to raise that to the 0 power. And then again, you can plug that into the calculator, and we should end up with 0.372. Okay. Now, as you work through this, the calculator will calculate a bunch of these at a time. You can imagine we kept the trials very small, like 5 randomly selected people or 4 shots. You can imagine if there were 10 trial runs or something like that, that you definitely don't want to have to list out all of them all of the time. So let's talk a little bit about how the calculator works. If I want to calculate the probability of, I'm going to go through and just talk about really quick how to use your calculator to do this. As far as using its distribution functions. So your calculator, if you push the button second, and then you push the button, it looks like varse, and it has the word distribution above it, or part of the word distribution. I'm going to show you really quick. This takes you into different types of distributions. There's normal PDF, normal CDF, all of that. We're dealing with binomials, so you'll notice there's one called binomial PDF and there's a binomial CDF. Binomial PDF is going to allow you to calculate the outcome of an exact value. Binomial CDF is going to allow you to calculate a cumulative amount. So let me show you back on the notes. What that means is PDF would be something like this, where there's an exact particular value that you're looking for the outcome probability for. A CDF is one where you have a cumulative sum of probabilities that you want added together. Now, the only trick with the calculator is that the CDF only does less than, so I'm going to show you how we would have to convert this to a less than idea in order to use the calculator. So first of all, something like this is actually super simple in the calculator. Once I know that X needs to equal 2, I know there's 4 trials going to happen, all I have to do is come to the calculator and input that different information. Now, some of you have really nice calculators, nicer than the app I downloaded and I'm using on this video. And it will specifically ask you how many trials, and you're going to say 5. And then it will say what is the probability of each trial? 65%. and then it'll say, what do you want X to be, right? How many successes? And you can tell it 4. Others, it will look just like this. So just remember, this is the total number of trials. This is the probability of success on a given trial, and this is how many successes you're looking for. So I'm going to jump down here and do this one. If I'm looking for 2 successes and there were 4 total trials, then I'm going to go to my calculator and I'm going to choose binomial PDF because it's an exact value that I want to find, not a cumulative sum. So I go to PDF. Again, there were 4 trials, and I'm going to put a comma. I don't know if you realize you have a comma on your calculator right by your parentheses. And then I'm going to put the probability of success. So the probability of success was 3/5 on this problem. Then I'm going to put a comma. And then it asks for how many successes I want, and we wanted 2 hits on this one. So if we push enter, that gives us that 0.3456. So it tells us the probability outcome would be that 3456 that we just found. Okay, so again, your calculator is just doing this part for you. Now, let's say, I'm going to write this off to the side actually. So this one I'm going to use a binomial PDF. If it's an exact number of, if it's like a whole number value that I'm... On this part C, I'm going to show you how we can use the calculator to do a cumulative distribution. So remember, binomial PDF is one specific value. Binomial CDF is when we want to use a less than or equal to. And again, your calculator only, the CDF applies to a less than or equal to a specific value. So if you know that X has to be less than or equal to a value, you can use CDF. Greater than, not so much. You would have to convert it to a less than or equal to. So we've got binomial CDF, and let's use it on this one. This says at least 3 misses. So our probability of success was hits. So at least 3 misses means, right, again, like we talked about before, that you hit 0 times or 1. Another way to state that is that your number of hits had to be less than or equal to 1. If that's the case, and I know that I want it to count 1 and all the possibilities lower than 1, then I use the CDF. And what it does is it adds all of those together, the value you give it, and every value lower all the way down to 0. So again, you would just go into your calculator, but instead of using PDF, so we're going to go to second vars. Remember to choose binomial, not normal. So we go binomial CDF this time. And again, it's going to look the same, so you got to know which one you're going to use if you're going to use these. Binomial CDF, you would put in, again, your total number of trials. So they were shooting 4 shots. The probability of success is still 3/5, and we want to tell it that we want it to be 1 and everything less than 1. So when you give it the 1 and you use cumulative, it knows what it's doing there. So again, we get 0.1792. If you look back at what we got originally, we got the 0.1792. So just recognize, and I'm going to write that out just so you kind of have it. In the calculator, we put 4. Probability of success was 3/5, and we wanted 1. And it did 1 and everything less than 1. On A, we did the probability here of X equaling 2. I don't know why I didn't write that on all of these. Whoops. And then we had 4 trials, 3/5, and we put in a 2. So this one, again, we used PDF, less than or equal to, you're using CDF. Okay, so give it a try on some of those homework assignments. If you get stuck on this is a challenging